You see a Christmas village behind me. We're in Carmel, Indiana. It's Christmas time. We're doing leadership development here. And as leadership development, what we want to do is bring thought leaders to the industry. This is a power panel that you're about to watch, you're about to sign up for. We know you love it. 3 great leaders talking about 1 or 2 issues. Join us. Power panels from APC Media.
My guests are Edward Casserly. Ed Casserly, he is from Ergon. Bruce Forsyth is with Cargill Biofuels, and Claude Beauchemin, he is with TJH2B. I always used to get those letters wrong, but Claude, I've got them because of you now. But let me have each of you take just a brief moment to introduce yourselves and a little bit about your company. We're going to start with you, Claude.
Good day, everyone. Thank you for this opportunity to share with you our collective experience. I'm Claude Beauchemin from TGH2B Analytical Services. I'm a chemist from training and formation, but I've been in contact with the electrical engineer all my life, so I'm almost an engineer by sympathy. I graduated from Montreal University in '76. In my previous life, for almost 30 years, was involved in transformer online monitoring, both for gas and other parameters. I joined TGH2B in 2011, so it's already 12 years, more going 13 years, and I've been Director of Technical Development in that function. I'm also a member for the IEEE, and more particularly today for the C57-104, the DGA guide. But I'm also a member of other organizations such as CIRE, IEC, ASTM, and Canadian Council for Standard. And I'm a member of the Order of Chemists here in Quebec. For those of you that do not know who TGH2B is, I could say in a few words that we are founded in 1978 in Sacramento, out of California. And actually, we are a worldwide association of 11 laboratories. So in North America, South America, Asia Pacific, and Europe. We offer testing and diagnostic for anything that is insulating, mostly liquids, but also solids. And we also sometimes offer consulting works if you have some special requirements. We're an industry leader in the development of condition-based maintenance in the sense that we early on develop approach to use a result from the lab to evaluate transformer and tap changer and breaker. And finally, we present yearly TechOn, which is a conference of representative of the industry that is held at various locations every year, where we share the latest development in the industry and discuss and have fun. Thank you.
You know, Claude, one of the things I love, and you just briefly went over it, TechCon is one of the events that I really appreciate every year because you bring a lot of utilities. So we're going to talk about that a little bit later. But Ed, if you'll just do the same thing, talk a little bit about yourself. Thank you, Claude. Ed, take it away.
Thanks, Alan. Good morning. I'm Ed Casserly. I received my PhD in organic chemistry from Rice University and began my career as a research chemist with Pennzoil, and I'm currently the senior scientist for Ergon refining in Mississippi. So I've been involved with R&D and technical support for especially petroleum products for 39 years now. I've got 7 U.S. patents with Pennzoil and additional 7 patents with Ergon. I'm a member of all the same organizations that Claude mentioned, IEEE, CIRE, IEC. Within ASTM, I am the vice chair, and this year I received the IEC 1906 award. A little bit about Ergon. Ergon is has the world's largest naphthenic refinery. and is a major supplier across the globe for insulating liquids. And we've broadened our portfolio recently, and so in addition to supplying naphthenic mineral oils, insulating liquids, we provide natural and synthetic esters as well. Thank you.
Excellent. Thank you so much, Ed. One of the things I like about Ed, he just goes over. I've got 14 patents. It's not easy to get one, let alone 14. So thank you for that, Bruce. Ed, I really appreciate it. Bruce, a little bit about yourself and welcome.
Thank you, Alan. Good morning, everybody. My name is Bruce Forsyth. I'm an electrical engineer, and I've been working in the transformer industry for just about 36 years. Most of my career has been in the design and manufacturing of distribution and power transformers. I've had the opportunity to be involved in transformers as small as 25 kVA and 34.5 kV class, and as large as 500 MVA, 500 kV class. I'm a member of several industry organizations, including CGRE, NSPE, and the IEEE. I had the honor of serving as chair of the IEEE Transformers Committee for the 2020 to 2021 term. I am currently the Global Application Engineering Manager for Cargill Bioindustrial. Cargill Bioindustrial manufactures and distributes FR3 fluid, which is a seed-based natural ester dielectric liquid that is a true bio-based, high fire point, biodegradable, and sustainable alternative to traditional mineral oils. And that's it for me.
It's funny when you use that many adverbs in a description of something. That's a lot of adverbs there. Gentlemen, thank you so much. One of the reasons that we were delighted that the three of you could join us is the expertise that you have demonstrated within the industry. And I love the fact that you're all involved with all of the different organizations that we're involved with, IEEE, with CGRE, ASTM. And as a result of that, you get to work together a lot. And we're going to talk about that in a little bit, some of the work that you all have done on the DGA committees. But one of the first things I really want to do, I want to start. And I'm going to, as I do this, I'm going to pick on you as to who starts first. And we will rotate who starts first, okay? But I want to start first with something that a number of people have asked me and said, hey, why don't you do an article? Why don't you have somebody do an article on the best or better applications for different fluids? Where do naphthenics fit? Where do natural esters fit? Where do synthetics esters fit? And my answer has always been, well, that's not for us to do. That's really for whoever writes a specification to do, whether that specification is for a new transformer. And we'll get into that about writing specifications in a bit. But I do want to talk about, just from each of your perspectives, I'm not saying best application, but for Ed, we're going to start with you for a better application of a naphthenic, and also now, since Ergon does produce synthetic and natural esters, where would you tell a new engineer coming into a utility, specifying new products for different classes of transformer? Is there a simple rule that he can apply, or is it just, it depends? So Ed, let's start with you.
All right, thanks, Alan. So first off, when you talk about either naphthenics or isoparaffinic, you have to realize there's a full range of mineral oils out there. The original ones were the naphthenics, and then there were paraffinic oils, which had wax in them, so they had high pour points, and then there was isoparaffinic oils. Recently, 10 so years ago, we started getting the gas to liquids, and in the last few years, we have the bio-based hydrocarbons. So there's a lot of different type of molecules that are parts of mineral oils. In addition, there's several different levels of inhibition. So you have totally uninhibited versus high grade inhibited. So those gives you different levels of oxidation stability. So basically, minerals have been around for the last, for the last century, since the late 1800s. And so they've been used successfully in all applications and voltage types, including free breathing applications. So if you want to look at what's been used historically, it's been the minerals, because those are the only thing that's been around that's been used. So the uninhibited minerals are generally used in less severe, lower voltage applications. So because they don't have the same oxidation stability as the inhibited. The inhibiteds have added synthetic antioxidants, and they are used for all applications and voltage types. But there's a few applications where they are not, recently they haven't been used as much due to non-electrical considerations. So they do have a relatively low pour point, and so they're not used in buildings where high fire point liquids are being used. The use of sprinklers and fire suppression can help mitigate the risk and potential damage of fires. But if you want to be safer, you'd put in a high fire point liquid, such as the esters. They're not typically readily biodegradable. And so if you're next to water or in environmental sensitive areas, you want to shy away from the mineral oils and use the natural synthetic esters since they are. So our hope is to educate the industry as to what the options are, and then let them make the educated choice of what best fits their application and their current needs. So there's a wide range for them to choose from, and it's, I don't want to say buyer beware, but it's a buyer's choice.
Buyer beware. I like that. Buy specify the wrong oil in a transformer and beware of the consequences. Bruce, if you could kind of take the same question, and what are the better applications that you would say? Now, I know you're with Cargill, which is a biofuels manufacturer, yeah. So there's a specific area that you focus on. But in general, where should somebody making specifications go?
Yeah. So, motivation is a tricky thing, and kind of what Ed alluded to there is that at the end of the day, it's up to the buyer to decide what's right for their application. But I will emphasize the fire risk is an application that the natural esters have a much higher fire point. So if a transformer is going to go indoors, or is in close proximity to other structures, natural esters are a good option to consider in those cases. Ed mentioned the proximity to waterways. If there's a risk of a spill of any sort, the natural esters are 99% readily biodegradable and generally non-toxic to the environment. So there's if there were a spill, there would still be, issues related to kind of preventing it, but it would prevent some of the long-term environmental damages. There's also, for life extension reasons, and I'll mention maybe at some point the natural esters have a tendency to keep the insulation a little bit drier if customers are looking to extend the life of a transformer, maybe overloading it a little bit. Natural esters have some characteristics that benefit that application as well.
Okay, excellent. So, Claude, you have seen testing, and TJ is very utility focused, correct? I mean, a lot of your customers are utility focused, and many times in industrial applications, we've seen a move to the natural and synthetic esters because there's a lot of indoor applications, right? Just to what Bruce alluded to. But talk a little bit about what you've seen in your career at TJ as it relates to either of these. From a specification standpoint, you're a member of organizations that write standards. So talk a little bit about that.
Well, first, Ed and Bruce did a nice job to describe the pro and con of both family of product. As far as history is concerned, I've been there long enough to remember the time where ester-based oil was simply a research project somewhere.
Yeah.
And I remember clearly that I was giving seminar in those years to how to interpret results from the laboratory to decide what to do with your oil. And I was telling the customer that, you use mineral oil, but they are coming from two places in the world. And sooner or later, one of those will close. And then you will be in great difficulty. But mercifully, some people are working on vegetable oil for your transformer. At the time, everyone was laughing. Today, it's become a choice. What do you prefer? And as Ed point out, there are some criteria to follow. We do see an increase in the use of non-mineral oil in the industry very clearly. We do see new liquids. We're talking about gas to liquid, synthetic, not paraffinic, but synthetic material, synthetic ester, and synthetic hydrocarbons. So there are a lot of activity there. And one thing is sure is that the advantage of the natural ester is you could renew it. So we talk about environment and biodegradability, but it's a renewable resource. And that means that you're not stuck if a well's got dry, or if a company decides that they no longer want to be in the business of doing transformer oil. Now, of course, as far as the lab is concerned, this offers a lot of challenge. We mercifully, the tests are the same for all the type of liquid. If you do a DGA, you do a DGA. It's the same gas. But the interpretation and sometimes the process to analyze it are subtly different or sometimes quite different. So we also have to take that into account. So when we receive a sample, it's important to know what it is, because you don't process a DGA for mineral oil the same manner that you process it for an ester-based oil. So they are changed. As far as specification is concerned, again, Ed rightly point out that at the end of the day, this is a customer decision. And of course, the manufacturer, the transformer have to know in advance what you want.
I love the fact that you set me up for the next question. Okay. I'm an acolyte of DGA. I think DGA, it's the number one test that everybody runs, right? In the utility industry, DGA is the number one thing they make decisions on. It took, I used 6 years. I said it took 6 years to update the DGA guide from the Transformer Committee. All of you have been involved in that. I mean, you've been going to these meetings and you're all there. 6 years is a long time to be able to upgrade the guide. I'm going to start now with you, Bruce. I pick on you first because I picked on Ed first, so be prepared for this. You know, there's a reason why it took 6 years. Now, it's because things keep changing, and you're trying to put a point down, and you're trying to say, "Hey, here's the DGA guide." And the minute that you do that, things keep changing, as all of you have said. Nothing stays the same. So, Bruce, why 6 years, and why is the DGA guide from IEEE and the DGA? I think the DGA guide is being worked on from IUC, correct? I think it's in process right now. Yeah. So why does it take so long to do that with wonderful experts like you all making these decisions?
Why does it take so long? That's a great question. It takes so long because, you know, one of the great things about the IEEE and the IEC documents is they're developed by volunteers. These are people that are involved in the industry and dedicate their time to come together and analyze the information that's available and try to come as a community to the best technical decisions that benefit the industry as a whole. There's a lot of different opinions involved. It takes time to aggregate data. One of the issues that took a long time with this most recent gas guide is gathering the latest and greatest information. Data that's available is key to making these decisions. You know, interpreting, Claude's an expert on this more than I am, but interpreting the DGA data is not a simple process. There's a lot of things that go on in a transformer that affect what's in that oil. And pulling these things together, getting the data to have statistically reliable results is a challenge and takes time. And then once we have it, as I said, aggregating it and analyzing it and coming up with the right information, understanding what that data is telling us, it takes time. And there are a lot of different opinions involved sometimes on how, and it takes time for all of those experts to express those opinions, to work them out, and to find that common story that best represents the state of technology today.
Excellent. Great. So, Claude, he set you up to be able to do now, because you see it in all of the results. And a lot of it is how do you interpret the data so that as an engineer, I want to know, give me some data, but give me some interpretation so I know what it means. But more importantly, I know what to do, right? Talk a little bit about the DGA gas guides.
Okay, first of all, Alan, unfortunately have to correct you. It was not 6 years, it was more like 15.
I know that, but I didn't want to say that.
Yeah, honestly, and what did happen, it's the work started in around, past a bit 2000, 2002, 2003 for the revision of the guide. And it got stuck. And as Bruce highlighted, it's all the volunteer that work on this, and the work is long. So in 2006, there was a vote at the meeting, I think it was in Montreal, where they decided to simply reiterate the guide as it with some minor correction because they were not ready to put something new on the place. And the work started literally at that time, but it was simply the continuation of the 5 or 6 or 7 years prior to that. And to make a long story short, we finally issued a guide in 2000. Well, we voted on it in 2018, and it got published in 2019. So if I count, depending where I put my starting point, it's a lot more like 15 than 6. And believe me, yes, it's long. And one of the difficulty is volunteers, so time that people could share with us. And here, by the way, I want to thank personally Dave Hanson's, my boss, that gave me the opportunity to do that. I mean, the amount of time I sunk in that guide, it was just insane. And any other boss will have simply pulled the plug and said, Claude, you have a day job, don't forget it. He let me work on it, and I have to thank him for that. The other item that is a bit a corollary of the fact that we're all volunteer is that developing a guide like this is herding cat, literally. You have a lot of different opinions, a lot of different point of view, and it become a kind of horse trading. Yeah, we said that, but no, you could not say this, and so on and so forth. And the data, we collected 1.5 million points of data. And by the way, thank you for the paper you published 2 years ago on this topic. Just the work to collect the data, clean it, because you could not use it, the raw data as it, then process it, and then ask question, okay, we got this result, it is meaningful, it is useful, and then having the discussion, and then start a computation again if we're not happy with it. Plus the complication of you have various suppliers that have various requirements in terms of privacy of the data and so on. So that was a major undertaking, and I'm glad that we managed it. And the other thing, to ask your question, how to interpret it, it is still an art. It is not an exact science. There are no question about it that you could not take a number and that answer all the question. You have to put everything in context. And we did attempt in this new version of the guide to explain what are the various contexts in which you take a DG. Is it for each run test? It is because we have a trip, or it is a routed test. You don't look at it the same manner. And we try to explain that the number we get has wide variability in function of each network. And you have to keep that in mind. If we tell you is 100, it doesn't mean that 99 is perfect and 101 is bad. I mean, it is in the range of. So passing all those ideas was a bit the challenge of writing that new guide.
Excellent, thank you. So Ed, you get to sum up all of that, and you can just say ditto, or because you've had experience, and as head of the Transformer Committee, you probably were pulling your hair out trying to get to solution? Because that was right after the DGA guide was. You were involved in it, and then you were the chair of the Transformer Committee, correct?
Bruce was chair of Transformer Committee. I'm vice chair for ASTM.
Okay, I'll say okay, but sorry about that. But same problem. You've got the vice chair of the ASTM, which is also a standards organization. Talk a little bit about why it takes as much time, whether it is an ASTM standard or an IEEE or an IEC.
Right. So there's basically 4 different international committees that work on insulating liquids. You got ASTM and IEEE, which are based in the U.S., IEC, and CGRE in the EU. So ASTM and IEC develop standards, so specifications for insulating liquids. IEEE and CGRE publish guides, like the maintenance guides. So, and you got experts, as they both gentlemen mentioned, are experts from around the world and from different disciplines. So you got chemists, analytical chemists talking to organic chemists, talking to electrical engineers, talking to mechanical engineers, and we don't all speak the same language. So there's that. There's the education between the different experts for them to understand your point of view. So it takes a while. So we want for the specifications, we want the things to be very exact. So, what is the flash point? What is the pour point? What is the viscosity? And we can do that and say these are all the tests that are important, but then we got to come up with what value to use. And so that's a little, like Claude said, a little bit of horse trading as to, is the flash going to be 140 or is it going to be 145? And everybody has their own opinions. And it all comes down to compromise and consensus. And so you have to work together.
Yes, Bruce. Bruce has got a question on compromise.
Well, really, I was just going to add that when the standards are developed, it never ends. It's not like it's over. Our standards are constantly under development. The challenge is deciding when to publish whatever's available today. We're not very good at drawing a line and saying, let's publish what we've got today. The engineers always want to say, no, we've got one more paragraph we need to add. We need to do one more little thing. We're not as good as the cell phone manufacturers that every September have a new model coming out. We tend to want to try to make that document perfect before it gets published. And sometimes that takes a little longer than it should. But that's an important thing, is that once it's published, a lot of times these documents are immediately open for revision because new information comes available.
Good. Sorry, Ed, I cut you off. Go ahead, Ed.
No, that's great. So there has been somewhat of a shift from the basic specifications as to what's the vis, the pour point, et cetera, is to performance-based parameters. So within IEC, we recently added a requirement for stray gassing for the inhibited high-grade oils within IEC 60296, which is a specification for mineral insulating liquids. So it's only required for that one product, not for the uninhibited or the trace inhibited products, but it's something that the end users were asking about. They were always asking about stray gassing. They wanted some sort of performance testing, and so it took a considerable amount of testing to define the test parameters that we used and to put in the limits for the high grade minerals. So there's a lot of discussion these days about performance based parameters. And one last thing is there's a growing number of liquids and other components, be the different types of paper and whatnot. So the whole system has to be compatible with all the other parts of all the other components. So you have to look at it as a system and not just a collection of different components. You just can't say, well, this is the best mineral oil or this is the best ester. You got to say this is the system, be it mineral and paper and all the different other components as a whole. And so that's one thing you got to make sure that everything works together.
Excellent. We do have a question from the audience. I want to answer this, but I'm not going to. Okay, I'm really going to focus this on both Ed and Bruce. But is it not concerning that both CGRI and ASTM and IEEE rely so much? Their committees rely so much on suppliers to give information to that. Let me start with you, Bruce. That's a question of, hey, is there an undue influence from suppliers in developing these standards?
I don't think there is. In fact, I've been involved in several of these activities where we're trying to gather information, and the information needs to come. We're really looking for the data from the users. We want to know how transformers are behaving in service. And so we, right now, there's several surveys out trying to gather DGA experiences, but we're focusing on users and sometimes manufacturers, depending on what type of information we're looking for. But at the end of the day, what we're trying to do is gather what's really going on in real life, and so that information has to come from the users. They're the ones with the real data that we have to get. Sometimes that comes from the service providers that they've used to gather information, but ultimately it's their data. That's what's really important, is gathering the real life experiences and being able to turn that into some sort of statistically reliable trend or data that can be used by the general public in general. So,
Ed, same question.
Well, the ASTM D27 and IEC TC10 are both the committees for insulating liquids and fluids. And so by default, they're going to be dominated by the insulating people, the liquids people and the gas people. There are other committees within ASTM and IEC that deal with the transformers or the components of transformers, and those are dominated by the end users, or the manufacturers and end users. But you're right in that we need more cross-pollination between the liquid people and the manufacturers of the transformers and the end users. And so we would love to have more utilities within ASTM D27. We have a few, but we definitely would love more. Same thing within IEC. So we kind of get pigeonholed into different groups because of the scope of that particular committee, but we welcome everybody to come in and get their input.
So, Claude, you mentioned Dave Hansen. Thank you for giving me time to do this. It took a lot of time. You know, that's one of the reasons that it's hard to get utility, the people who are actually involved in it, because you're asking them to give up a lot of time, right? And you got to have a boss that's willing to do that. But Claude, same question to you. As you've been on these committees, what would you say about that? Because you're not a supplier, but you are a supplier of testing information. Yeah,
supplier of service, so to speak.
Yeah, right.
The short answer is, listen, if you feel that the producer are overrepresented, do something to correct it. If you're part of an utility, come. We don't refuse anyone, believe me. It is an issue because often those utilities are public, and things like transportation costs and living are highly regulated, while the producer, which are private from business, usually are more open to spend money, on a trip or on travel. If you're an utility and you have a high AAE that is in Washington, D.C., you have to get the permission to get there, and approval and all that is a complex process. And it's probably one of the things that limits the number of people from a utility. But they are welcome. It's not because we don't want to see them. We do want to see them. We do need them. Please come.
Ed, you've got a comment?
Yeah, so within ASTM, it's one vote per company. And there's a limit to the number of producers that can be voting members on the committee. So they recognize that they don't want the producers to overwhelm everything. And so there's a limit to the number of the voting producers that are out there. Within IEC, it's one vote per country. And so that country national committee is going to be composed of, different people from different organizations. And so, but they vote as a country, not as individual companies.
Excellent. Well, that's a good way to control it. Of course, the small companies then, countries get a lot of influence that the big countries would say is unfair given the, anyway, that's just another thing. Yeah, that's just another thing. Maybe you all can work on that and do it by population. If you have 10 million, you get et cetera, et cetera. But I think that's a great answer. Yeah.
It's complicated enough as it, please don't make it worse.
But so let me give you my answer, and you all have said it. If you want to be involved, get involved. And I know the integrity of the people involved that are making these decisions and why it takes so long. And I would say, trust the integrity, trust the character of the people doing this that are willing to come to these things. And the three of you gentlemen represent the kind of character of the people that hash these things out. Yes, Ed?
Well, within IEEE, they ask that you not represent your country or your company. You represent your technical expertise, and so you vote as you feel you should vote as a technical expert.
Right. So to answer that question, I think it's incumbent upon people that want to be involved and have a problem with it to be part of the thing. Let's switch to our last topic. And the last topic is something that I love. We're going to be doing a lot this year with talking about changes to the system. I was recently doing interviews at the Seagray Grid of the Future event. I'll be a panelist at the TechCon conference. We'll be doing interviews at IEEE PES T&D this year. We did interviews at the Grid Edge conference with IEEE last year, and are looking forward to Seagray Paris to come and do interviews there. But why we do that is because there's probably been more change in the last 5 years, maybe 10 years within what we call the grid. Right? Then there has been, because with all of these renewables coming in, you change the nature of a grid. You add a lot of inverters into the system, which cause greater harmonics, greater transients. You have overheating or a greater heating of particularly transformers, both in-service transformers, and then you have to adjust to the new specifications. For a quick, let's talk a little bit about, am I right? And we're going to start with you, Claude, about the changes we're seeing in the smart grid, and or are there more that we need to be aware of?
Well, change is the name of the game in that industry. I mean, at first, when I started to interact with IEEE, I was a bit taken aback by how conservative the people were in the electrical industry. It took me a while to realize that they were not that conservative at all. Things were changing a lot. Now, what will come, you point already, for example, to the harmonic, filtering of the harmonic due to all those inverters. That's one issue. We start to tackle it. We start to understand it and make change in the way we design and build transformer. We will need other. For example, loss, okay, the efficiency of a grid. There are a lot of loss in the distribution more than in the transportation. And the reason is, well, they use small transformer, and small transformer is the lower bider possible, which will skim on the material, which will increase the electrical loss of that transformer, but make it cheaper, so we'll get the job. So maybe eventually we will need to have some more specification of how much loss is acceptable in a given transformer. Future. Now, the only thing I could say about the future is I have no idea what will come to us. I mean, I have seen so many change that I could make wild guess, but they will be that wild guess. The thing will change. The only thing I could be sure of, thing will change.
My greatest and my number one line is the only constant is change. Anyway, Ed, same question. Where are we in this transition?
Well, within the mineral space, the technology for producing mineral oils is improved greatly over the last few decades. And so we're using severe hydroprocessing to make a cleaner and more stable oil, which would be better used in more severe conditions. So the trend is going that way. So, and if you look at change that is going on in the last few years, well, it's been about 12 or 15 years that the GTLs became available, and those are fully saturated, inhibited isoparaffinic oils. Recently, in the changes for the using vegetable oils, the triglycerides, you run those through a refining process, and you get hydrocarbons that are just like mineral oil, except they're generated from vegetable oils, and so they have a low molecular weight, so they're readily biodegradable. So this is one of the new biodegradable hydrocarbons, and they have a low viscosity, which helps you in heat management. So, and everybody's concerned about sustainability going forward, and mineral insulating liquids have had a long history of use and reuse. They can be reconditioned, reclaimed, re-refined over and over, and so that gives you a lower carbon footprint and increased sustainability relative to just a one-time use. And so we have seen these changes over the last few decades, and quite frankly, we've now, it's taken us a while, but we come to embrace the change. And so due to that, we broaden our product portfolio and now offer the natural and synthetic esters to serve the industry today and into the future. So you're right, change is coming, and you better adapt.
Right. And Bruce, Cargill, which, represents the biofuels part of this, you've seen a lot of change. And I think Claude mentioned it. When they were doing research on using esters, has now no longer research. It is application, and that's what you all have been working on globally. But talk a little bit about what this change has meant.
Sure. Well, and the use and the introduction of the use of esters in transformer applications is a part of the change that you're talking about. It's not really that new. It's been around for 20 some odd years, but it's really just taken off in the last several years. There's a lot of issues associated with concerns about the environment and things like that have caused users to express a stronger interest in using esters, but the technological changes as well. In any time you change technology, there are unknown unknowns that surface, and one of the great things about our industry. And one of the things I like about all of the volunteers involved is there's a lot of really bright engineers out there that when these new challenges come up, they're able to find a solution to it. And we keep moving forward. You mentioned inverters with solar farms and wind farms. The use of inverters have introduced new stresses on transformers that can be predicted, but there have been some surprises in service. They introduced some harmonics. You talked about heating. There's some partial discharge issues that have been observed, and we've discovered sometimes some surprising solutions when these things happen. It forces us to get smarter about what we're doing and improve the products that we're building for the future.
Next question. Excellent answer. Go ahead, Claude. Continue.
Another thing that I have observed, it's the maintenance of the oil has improved tremendously in the past few decades. When I started, the philosophy of transformer oil is you test the oil. If the dielectric is bad and the water is bad, well, you throw the oil out, you send it to the bunker room or the boiler rooms, and you replace it. And today is a lot more, wait a minute, that oil is costly, is not easy to get. What could we do to maintain it in service as long as possible? And that's result in a certain number of tests. For example, we monitor the consumption of inhibitor in the oil, which was not done 40 years ago. So we have now a better perception of what is needed to keep those existing oil in service as long as possible. And Ed mentioned things like refining, refurbishing of the oil. It could be quite an involved process just to reuse the pine stock as opposed to throw it away. That's another big change we have seen in the last few decades.
Excellent. Gentlemen, we have a lot of questions, so we're going to move to the question and answer. And when we're done answering the questions, we're done, or we're going to be done in another 15 minutes. So hang with us here. I'm going to answer the last question first, because the question is, hey, Bruce, you said over 20 years of ester use, but it really is over 40 years in transformers growth globally. Is that correct, Bruce?
Yes.
Yes. Okay. Done. Thank you very much. By the way, that's the easiest question. Okay. Some of the questions relate to specific people, but the others may have a response. So I'm going to start when I do the question. I'm going to start with somebody, and if it answers it, we're fine. So you don't need to weigh in unless you need to weigh in. The first one I'm going to start really is with you, Claude. Is there a documentation that users can identify, that you all are the people I think they're referring to, that describes the different dielectric properties of mineral versus esters and what to expect in terms of test results? Is there documentation on that? I would assume there is.
Well, unfortunately, they are not a nice handbook I could refer to that will contain all those information. In fact, it's a work in progress. At IEEE, for example, we have maintenance guide for various liquids, but they are still specific to a liquid. So you have a maintenance guide for the ester, and you have a maintenance guide for the mineral oil, and one for the silicone, and so on and so forth. We are starting, so to speak, the work of combining them, at least that you could find it in a single location. But there are a lot that have been published. I just could not point you to a single one. One thing I would suggest is, if you're not a member of Cigarette, get your membership, and then you go on the Cigarette site, and they have what they call technical brochure. And if you're a member, they are free to download as a member. And those brochures are written by group of experts, and they do cover topics like this. For example, presently, I am in 2 Cigarette working groups that will eventually be a technical brochure. One is on the drying process of the transformer, and the other is precisely on the question of which tests mean what for which oil. This one is ongoing, and it will be probably a few years before it gets published. Michel Duval has been convener of several of those work and published a lot of things on DGA interpretation through the year. Okay, the frontier of DGA, the latest in DGA. So Cigarette, membership, and the library of Cigarette. If you're not member, you could purchase them, of course, but if you're member, they are free for the taking.
Yeah, those are have been incredibly helpful in my career, and I think it's $120. Get your boss, put it on a MasterCard. Get your boss to do as an expense in your travel thing. So both Cigarette and IEEE have been invaluable to me to really understand those things. And anybody else comment, Ed or Bruce, on what we just talked about?
I was just going to say there's a lot of academic papers that have been written over the years. People from University of Manchester had a big project where they looked at all different oils, and they published a ton of papers.
University of Manchester,
yes.
Where my brother lived for the rest of his life and passed away in Manchester. Okay. I've got some that I'm going to come to you specifically, Bruce, because they are for you, and I'm combining 2 questions. One of them is the performance of esters in cold temperatures and gelling of esters. Talk a little bit about that.
Okay, so there's a lot of what I consider misinformation about cold temperature application. There's any liquid that's in a transformer for cold temperature applications is going to require some degree of, particularly in a cold start procedure, whether it's mineral oil or an ester liquid. It's very important today because we're in an environment now where for many, many years, mineral oil was the only liquid used. Today, there are different liquids that are available. It's very important to know what liquid is inside that transformer and to follow the appropriate cold start procedure for that liquid. Yeah. The great thing about an ester liquid is that it maintains its dielectric strength at low temperatures. During cold starts, I don't think we have time to really go into all of the details, but mineral oil actually loses some of its dielectric strength at cold temperatures just because of the nature of the saturation limits of the liquid. And the risk of a dielectric failure is higher during a cold start with a mineral oil transformer than with a transformer that's filled with an ester. But there are certain things you have to be concerned about. You want to make sure that the liquid is flowing. Any transformer under cold start conditions, typically you will energize the transformer without load and let the liquid warm up a little bit before you start applying load. So I think that there's certainly some differences in the viscosities of the materials. Very important that the users understand what liquid is in the transformer, and for cold start applications, they follow the correct procedures. Once it's running, the liquid is flowing, and there's no concerns.
Okay, good answer. Ed, since you produce both, and you're same answer, or would you add?
The only thing I've heard in terms of cold starts with esters is if you got tap changers, you got to make sure the taps are in the right position, because if they're not, then you can't get them to the right position when it's cold. So that's the only thing. Like Bruce said, follow the procedure, and it's not a problem.
When I was in the military, one of the things they said was follow the book. If the book says you do it this way, do it this way, because you need to standardize. You can't come up with your own answer. Here's a really good question that I think is kind of misunderstood in the marketplace. There's a recent, you answered that already. This is the one. We have these standards for power transformers, right? But is there a way that we could look at creating standards for instrument transformers regarding oil parameters? And I've always wondered about that. Is we have standards for power transformers, we have standards for other, but we don't have standards for instrument transformers. Is there a reason for that in general? Thoughts? Start with you, Ed.
With me?
No, I have no thoughts on that.
Okay. Yeah, it's because you don't deal with instrument transformers.
I don't do it.
Bruce, what's Cargill's approach to this?
Well, I'll go back to my IEEE experience. There are some standards for instrument transformers, and the need for any standard comes from the marketplace. And if there's a need, we need people to come and say, this is what we need. And the IEEE in particular is very open. If there's a need for a standard, and it's raised at the IEEE, the Transformers Committee, we create groups to work on those standards. So if there's a specific topic that somebody's interested in, bring it up at one of the IEEE Transformers Committee meetings, and it will get addressed.
So Gustavo, who answered that question, show up at the Transformer Committee meeting and say that you need a subcommittee to work on instrument transformers. Mm-hmm. Or is that a good answer? Is show up. And if there is a way to do it, it'll work. Anything to add to that, Claude? I don't want to leave you out.
As far as the lab is concerned, the main issue with instrument transformer is their very small volume. So they have a little amount of oil. Often they don't have a sampling valve, or they don't even have a valve in some case. So we do not see them as often as, say, a main transformer. But we do see them once in a while. And we are aware of a few differences there. But you're right. If you want more, show up, and we'd be glad to entertain you.
Great, Claude. Bruce, yes, sir.
I just want to emphasize there is a subcommittee within the Transformers Committee dedicated to instrument transformers. So there's a group that's already there, ready to tackle any challenges that aren't being addressed.
So, Gustavo, show up and work on a committee that's already there. Excellent. Another question that specifically, the question is kind of, I'm not sure where it came from or what it means, but what role did the fact that it creates exclusivity for some suppliers, did the fact that a stray gassing requirement was added to high grades of mineral oil? I'm going to take that to you, Ed.
Well, we added it for just the high grades because all the inhibited high grade oils did not stray gas. Okay. Even under the more severe conditions with a copper strip and oxygen. So that's how we came up with that. With the uninhibited oils or the trace inhibited oils or things like that, we saw stray gassing, and it varied. It varied all over the map, so we weren't able to come up with a limit for those particular types of oils. So we limited to just the inhibited high grade, not the inhibited standard grade or the other types.
Excellent, thank you. There are some other questions that really specifically apply to each of you, and I don't want to get into those 5 minutes before we're supposed to be through here. So in a quick summation, right, take a minute and just talk about what you would talk to me as a user, kind of a summation of oil and transformers, whether it's synthetic, natural, or whether it's esters, natural or synthetic, or whether it's mineral oils. What should I be concerned about and aware of? And I'm going to start with you, Claude.
Well, it's very simple. Know your oil, test it, see what's in there, see if it changed. Take good care of your oil, and your oil will take good care of your transformer. It's as simple as that.
We should write that quote down. Take care of your oil, and your oil will take care of your transformers. Because you know what? The life of the transformer is the life of the paper, and the oil helps make sure that you maintain the life of the paper. Anything to add to that summation, Ed?
Not just know your oil, know your supplier. So it's all about consistency and service. So your supplier should make consistent product day in and day out, and they should be able to service you whatever service that you require. And if that means going out and auditing them every year or so, go out there, get your boots on the ground, see how they're making their product, and make sure it's up to your standards.
Excellent. An equal playing field. You can make it cheaper, but you may not make it better. And that's an interesting thing. Bruce, anything to add? Summation of our hour together.
Well, I think it's a common message. Know the liquid. We're at a time now where transformers are being designed not just with mineral oil, and the reality is that the performance characteristics of mineral oil and esters are different. It's important that the design engineers know that. They're gathering information through usage and experience. And the users also need to be aware of what liquid is inside that transformer, because it will affect some of the decisions that they have to make with regard to maintenance or just the behavior and operation of the transformer.
And I'm going to sum it with this. I complained to these three gentlemen who are heavily involved in developing this that I was never invited to the Transformer Committee, and they all said, you don't need an invitation. You just show up. And so I'm going to show up, and you guys are going to see, because I think it's incredibly important, the work that you do on these committees. Claude, you've got one more thing you want to add.
Yes, if you do show up, and I could not invite you, as you point out, you don't need an invitation. But if you do show up, be careful if you open your mouths to offer you time. We will take you to your offer.
Yeah, you'll be on it. You show up and you say, I think, and then because you say, I think, then you're assigned.
I hear volunteer.
I don't. That's excellent. That's a great way to do it. Gentlemen, Ed Casserly from Ergon, Bruce Forsyth from Cargill, and Claude Beauchemin from TJHB. Gentlemen, thank you so much for sharing with our industry. We will publish this publish it as an interview, just like we've done, and we will also transcribe and publish in some way. Excellent. Thank you so much. This has been a Power Panel discussion. Power Panel is a product of APC Media.